Okay, we're going to have a look at another circle theorem. So this time, this circle theorem refers to angles at the center or twice the angle at the circumference. So if we have a center of a circle here, and then we basically pick 3 points on the circumference. So if I pick one here, and one here, doesn't matter where I choose them. If I join from this part on the circumference to this part, and then I do the same here to form like an arrowhead, and then I take the point on the circumference and bring it into the center, and then do the same here. So it looks a bit like the quadrilateral, which we call a delta. Okay, so what we're looking for here is if we measure this angle here, the angle is 34 degrees. And what we're looking at is also this angle here. And what we should find, hopefully, if this is an accurate drawing, is that this angle here, because of what this circle theorem is called, is actually double. This one is double the angle at the circumference. So the angle at the center should be double the angle at the circumference. So in theory, this should be 68. So let's check. So let's line this up. Let's go around. So line it up, look at the inside scale, 68, perfect. Okay, so this is 68. So this circle theorem is called when you have points on the 3 points on the circumference, and you extend these points to the center. The angles at the center are double the angles at the circumference. So if you had to describe this in an exam situation, that's the wording you would have to use. Angles at the center are twice the angle, the size of the angle at the circumference. Now, how do we apply that to an exam question? Well, here's an exam question. So ABC are 3 points on the circumference of another circle, just like we had on the example I've just shown you. O is the center of the circle, and it tells you that the angle here, which is the angle at the circumference, is 112, and it basically says work out the side of the angle ACB, which is this one. So we've been given the angle at the circumference, at the center, and we want the angle at the circumference. Now what we've just learned is that the angle at the center is double that at the angle at the circumference. So we know that we just need to halve this value. So we will be doing 112 divided by 2, which is 56. Very easy marks to get in the exam. And if they asked you to describe why, you would say because angles at the center are double the angles at the circumference, and that's all we need to say.